Hello, hello, hello. Welcome to this wonderful Wednesday. So, when last we talked, I started out with the first two on the whole perimeter and area idea, and I asked you to try and get to number 9. Let's take a look at 3. 3 was in your packet, but from a very, very long time ago. I think this might have been the Thanksgiving packet, to be fair. So let's take a look at how I would find this side. Now, if we take a look, we've got this bright blue triangle. Isn't it pretty? And we've got this angle down here. Now I've talked about SOHCAHTOA, which means we need to label our sides. This one's going to be the hypotenuse. This one's going to be adjacent because it's between my two angles. So this one's going to be opposite. First thing I want to do is I want to find x. I want to find this opposite side right here. So we are going to do sine of 30 is equal to opposite, which is my x, over hypotenuse, which is 12. And you can either menu 31 that sucker, or you can solve it the old-fashioned way. Just depends on how you're feeling. Regardless, you should get x equals 6. So we've got x equals 6, which would be awesome if it asked the height of the triangle, or the rectangle. If it asked for the height of the rectangle, we would be done. Unfortunately, it asks for the perimeter. Perimeter means we have to add all sides. So we just got this 6, that's this side. And this side, since it's a rectangle, got to be opposite sides are equal. I need to go back and I need to find this side now. I need to find from B to C. So that's going to be a cosine problem. Cosine of 30 equals adjacent, which is my y, over my hypotenuse, which is 12. So 12 cosine 30, y should be 10.3923. Once again, we're going out 4 decimal places because we're not done yet. That sounded really creepy. It sounded like I was going to go murder someone. It's possible. You don't know what I'm doing. All right. And then we add up all of our sides, and we should get our 32.8. I told you 4 was useless and annoying, and I don't like it. It's not useless, but it is annoying and I don't like it, so we're not doing it. Let's go to number 5. Yeah, I can say I don't want to do it, and we don't have to do it, squirrel. That's what canceling the regents means. I have full power. Okay, which was creepier? All right, Linda is designing a circular piece of stained glass. So let's do a circle. Circular piece of stained glass with a diameter of 7 inches. Diameter means all the way across, 7 inches. She's going to sketch a square inside of the circular region to the nearest tenth of an inch. The largest possible length of a side of the square is this. Okay, so she's going to sketch a square inside that circle thing. Now, I've seen a lot of people try and do it this way, which is technically a square inside of a circle, but it doesn't let you use the diameter. I want to use the diameter. So if I have the diameter, that makes my square like this. That's also a square inside of the circle, but now that 7 is actually helpful because I've got that triangle down there. Well, with a square, all sides have to be equal. So I've got x and 7. In order to solve for the missing sides, a squared plus b squared equals c squared. X squared plus x squared equals 7 squared. Once again, you can just do menu 31 at this point. I like to do it out. I've got 2x squareds equals 7 squared. 7 squared is 49. And then I divide both sides by 2. So we get x squared is equal to 24.5. And then we square root that 24.5. And we should get x is equal to 4.94. Yay! 4.9. The largest possible length of the side of the square is 4.9. Notice we can't round that up to 5 because that would leak outside the circle. Okay. Number 6. Number 6 was again in our notes packet. If we take a look at what's happening here, I want to find x. Well, x is just this piece, which corresponds to this piece, which corresponds to this piece. So really, they're doing a fancy way of asking me what is half of the circumference. So circumference is 2 pi r, a circle with a radius of 5. Okay, so the full circumference would be 2 pi times 5. So 2 times pi times 5 is going to be 31.4159. And it's saying I only want half of this, so divide by 2, and we get half of my circumference is 15.7-ish, also known as 16. Because now it says to the nearest integer. Nearest integer means we're rounding up because 15.7 is closer to 16 than it is to 15. Okay. Triangle RST is graphed on the set of axes below. How many square units are in the area of this guy? Okay, a lot of stuff right now. My favorite way to do this is to block it off. We've got a nice big chunk right here. We're going to block this. We've got how many boxes on the bottom? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 right there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's a 12 by 12 block. So if I were trying to find the area of the square, the big purple square, area would be base times height, so that would be 12 times 12, which would be 144. Okay. Now that I've got 144, that's exciting. But that's a whole lot more than what the actual triangle is. I want to find this pink triangle inside. I want to find the area of that guy right there. Okay. So in order to find the area of that dude right there, I am going to have to cut off this blue triangle. If I take the purple box and I cut off the blue triangle, I'm much closer to the pink triangle. So the blue triangle area is equal to 1/2 base times height, 1/2, 12 times 6, also known as 36. Okay. And then I want to cut off this green part. And after I cut out that green part, I want to cut out this yellow part. So let's cut out the green part. Triangle for the green part, area equals 1/2 base times height. It was 6 units by, that's 3 units on top, equals 1/2 6 times 3, which gives me a 9. And then we're going to do the yellow. Yellow triangle is area equals 1/2 base times height. And it's 12 over here. And what is that, 9 over there? Looks like 9 boxes over there. So 1/2 9 times 12. So times 9 times 12 equals 54. And what I'm going to do is I'm going to take the purple total, so the 144, the whole thing, and then I'm going to subtract off. I'm going to cut off the blue piece, and I'm going to cut off the green piece, and then I'm going to cut off the yellow piece, and that's going to leave me with my pink piece. How fancy. And you should get 45 when you do that, which, hey, is an answer. That's super exciting. Next one, number 8. Type of bacteria is grown into petri dishes. We've got a diameter of 51 and a diameter of 75. So I've got A dish and I've got B dish. And we're going to start with the area. Oh, that looks too much like a proof. That just scared me. Okay, looks too much like an area. So area is pi r squared when we're talking about a circle. So A is going to have a diameter of 51. Diameter does not help me. 51 divided by 2 gives me pi times 25.5 squared. So the area of this guy is 2042.8206. All right, and we have to cram this many people in it. So if we're cramming this many people, these bacteria are not social distancing. Let me just tell you that. That's not happening. Okay, so density is how many people we have. We're going to spread that out. We're going to divide that up into how much space we've got. So we're going to take the 4,000 and we're going to divide it by this beautiful number that we just came up with, and we're going to get the density is about 19.58 bacteria for every 1 millimeter squared. They crammed in there. Okay, let's talk about B. Is B more crammed, less crammed? Well, it's certainly got a bigger space, but it also has a bigger population. Okay, area equals pi r squared, pi, stupid, diameter of 75. You couldn't even make it divisible by 2? Another reason why Izzo hates the Regents. Okay, so we're going to do pi times 37.5 squared, and we're going to get 4417.8647. Beautiful. And then how many bacteria are squeezed into this guy? Density of 72,000 bacteria over this much area. And how many, for 1 little millimeter of space, how many bacteria crammed in there? 16.297, round that to 3. So, which one's more cramped? This one's more cramped. A is more cramped because it has more bacteria crammed in a smaller space. So A is the people who are not social distancing. Bad bacteria. Bad. Also, I might be going crazy in here. It's a possibility. All right. Gallon of paint will cover approximately this many square feet. Artist wants to paint the outside surfaces of a cube. Oh, that's just mean. Okay, so we got a cube. Cube looks like this. Unfortunately, we want the outside spaces of a cube. So we're going to unfold the cube. Do you remember when we did that, what was it, Play-Doh lab? I feel like it was a Play-Doh lab where I brought out my little shapes and I unfolded them, and then we had to find the surface area. That was not fun. Okay, So let's make a nice big cube. And we have now unfolded the cube. There are 6 sides to a cube. We know that because if you were to do a dice, 3 sides are showing, 3 sides are not showing. That makes 6 sides. Okay. An artist wants to paint all the outside edges of the cube, measuring 6 feet, or nope, 12 feet on each edge. So 12, 12, 12, 12. Just put random 12s there. Okay, so if I wanted to paint this surface, this piece right here, it would be what, a 12 by 12? So my area would equal 12 times, or base times height. So that would be 12 times 12, which is 144. And there are how many sides of that cube? 6 of them. Okay, so the area that he wants to paint, so we'll call that the painting area. Paint area is 6 of the 144s. And that gets us 864 feet squared. Squared because we're looking at area. Okay. The least number of gallons of paint. Okay. If I ask you how many gallons of paint I need, and you give me 864 feet squared, I'm not going to be happy. That's not a Regents thing, that's just a general thing. If it asks for gallons and you give feet, the Lowe's people will not be happy. They're going to want, how many gallons of this paint do you need? You're not going to say, some feet. Okay, so we need to do a conversion here. There's got to be a conversion somewhere, and there it is. I skipped it up in the beginning. A gallon of paint will cover. So 1 gallon of paint equals 450 feet squared. So we're going to take that 864 feet squared, and we're going to do a conversion on it. We're going to use this conversion. Feet has to go on bottom because the feet squared then need to cancel out. 1 gallon goes on top. So we get 1.92. Okay, 1.92. Now we want to figure out how much paint he needs to buy. If he buys 1 gallon, is he going to have enough paint? That would be a no-go. He is not going to have enough paint if he only buys 1 gallon because he needs 1.92, so almost 2 gallons. So I'm going to tell him to get 2 gallons. I mean, technically when he goes to Lowe's, he could get 3 gallons, but that's just going to be a waste of money. And ain't no one going to waste money at this point. All right, so that is how we deal with perimeter and how we deal with area. In our next video, we're going to go on and talk about what is happening with rotational volumes. Remember the rotational volumes with the crazy guy? He was feeling up the pottery. It was terrifying. We got that potter's wheel and the guy was spinning, and we had that triangle that then made a nice cone, or this rectangle that then when we spun it around, that looks like an ugly cylinder. It made a cylinder. Yeah. Okay, your mission is to go and do 1 through 8. I will talk about them next video. I think my next video is going to be on Friday. I'm also thinking of postponing this whole break packet. I think I want to give you guys more time because, I mean, we're in the middle of quarantine, and this is one of my favorite units, and we haven't done it since December. Yeah, I think I want to give you guys some more time with this, so you really understand my love for volume. I know, I'm a weirdo. I'm okay with that. So let's say instead of having it due, yesterday or the 20th, I'm going to extend the date again just for fun. And I am going to put the due date on uh, April 27th. April 27th is your new due date, and I will then do a video on April 27th about how to do your pictures so that you can send me all of this good stuff so that you can get credit. Although for the most part, my class is going to go to, I'm not going to nitpick every detail anymore. I'm going to be doing a, if you participate and if you try, you'll get a good grade. Seems better. I'm getting really lazy. Squirrel, I think there's a problem. Oh well, we'll talk about it later. Once again, packet will not be due until April 27th. Another video will go up on Friday where I talk about these, 1 through 8, and I start talking about how to get density in there when we've got volume. All right, thank you very much. Have a wonderful day.